The aim of this experiment is to carry out the below mentioned chemical reactions and to classify them as physical or chemical changes. So the first reaction would be reaction of iron with copper sulfate solution in water. Then we'll be burning magnesium ribbon in the presence of air. We'll react zinc with dilute sulfuric acid. We'll be heating a solution of copper sulfate, or we'll be heating crystals of copper sulfate. Then reaction of sodium sulfate with barium chloride in the form of the solutions in water. So the chemicals required for the purpose would be a magnesium ribbon strip, some granules of zinc, then iron filings, solution of copper sulfate as well as crystals of copper sulfate, dilute sulfuric acid, solution of barium chloride, and solution of sodium sulfate. Now the first type of reactions, we all know that there are different types of chemical reactions, and we'll be talking about what are the different types of chemical reactions. So the first type is displacement reaction. Displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its salt solution. So when we add iron filings to a solution of copper sulfate, what will happen? Iron is more reactive than copper, so it will displace copper and occupy its place. So iron will push out copper, resulting in the formation of iron sulfate, and copper goes out. Now, whenever you'll see such a reaction happening, what will happen? The color of copper sulfate solution is blue. In fact, almost all solutions of copper salts, they are blue in color. And when copper sulfate will get converted to iron sulfate, the color will change to green, because salts of iron, they impart a green color. So that is how we identify this reaction. Let's see how this reaction works. Also, this reaction is going to be a chemical change because entirely new products are being formed and you cannot reverse the reaction.
Let us see how a displacement reaction occurs now. I have taken copper sulfate solution and iron filings. So we are pouring this copper sulfate solution in this test tube. You can see the color is blue, and then we add some iron filings to this. We'll keep it for some time and you can see the change in color. You can see the color is now changing to green. The more time you keep this, the deeper green it will get. So you can observe the change in color. So it was initially blue and now it is green. You can see the difference here. So this is basically because when iron filings are put in a solution of copper sulfate, iron is more reactive than copper. It displaces copper sulfate from its solution, resulting in the formation of iron sulfate, which is green in color.
The second type of reactions are combination reactions. Combination, as the name suggests, two things combining to form one. So when two or more substances combine to form a single product, the reactions are known as combination reactions. This happens when you burn a magnesium ribbon in the presence of air. So when we burn a magnesium ribbon, it burns with a dazzling white light, resulting in the formation of a white ash-like substance, which is magnesium oxide. So we'll see this in the activity that follows. And yes, this is also a chemical change because it cannot be reversed.
This is a strip of magnesium ribbon that I have. Let us see how it burns when introduced to a flame. Look at the dazzling white light that is emitted. And if we collect this ash in a china dish, you will find that it is white in color. So this is a characteristic of magnesium ribbon, that it burns with a dazzling white light, and the ash that it produces is white in color. So you can look at this itself, it is so white, and if I put it in a china dish, you get white ash out of this.
The third reaction we are going to talk about is how metals react with acids. So the experimental reaction involved in this is reaction of zinc granules with sulfuric acid, with dilute sulfuric acid. So when we add a few granules of zinc to dilute sulfuric acid, we see zinc sulfate is being formed and bubbles of hydrogen gas are given out. We can test this gas by bringing a burning splinter close to the mouth of the test tube in which we are carrying out this reaction, and we will see the bubbles, they will explode with a pop sound, showing that the gas evolved is hydrogen. So this is again an example of a displacement reaction, and yes, this too is a chemical change. These are some zinc granules and dilute sulfuric acid that we have taken. Now I'll be taking some zinc granules in a test tube. As you can see, we'll add dilute sulfuric acid to this test tube and see what happens. Look at the test tube very carefully. You'll be able to see the evolution of bubbles taking place. So you can see that bubbles are coming out. So when zinc reacts with a dilute acid, it gives off hydrogen gas. So the bubbles that are being formed here are the bubbles of hydrogen. And along with that, if you touch the test tube from outside, you'll feel it's warm, showing that heat is also being given out during this reaction. The fourth reaction is decomposition reaction. As the name suggests, decomposition means breaking down. So whenever a reactant breaks up into two or more products, we say it's a decomposition reaction. When we heat crystals of copper sulfate, which are blue in color, the color changes to white because copper sulfate is CuSO4.5H2O, that is hydrated crystals. On heating, the water escapes in the form of water vapor, resulting in the formation of anhydrous copper sulfate, that is only CuSO4, which causes a change in the color. This reaction can be said to be a physical change because as soon as you leave the crystals exposed to air, I mean the white crystals, they will again turn blue by reabsorbing the moisture from the air.
Let us see how a decomposition reaction happens. Now in this case, I have taken crystals of copper sulfate in this test tube. You can see they are bright blue in color. And when we heat them, just observe it very carefully. Look at the change in color and also look at the mouth of the test tube. You can see that the crystals, they are turning white. So this is a thermal decomposition reaction because the decomposition is happening due to heat. And at the mouth of the test tube, if you see closely, you can see some water droplets here. It is the water that is escaping out from the crystals of copper sulfate because copper sulfate has 5 molecules of water of crystallization associated with it. When we heat it, these water molecules escape, forming a condensate inside the test tube near the mouth of the test tube because that is the part which is comparatively at a lower temperature. And the crystals, they have turned white. Look at it carefully, you can see the water droplets inside the test tube. So this is an example of a thermal decomposition reaction.
The fifth experiment or the fifth reaction involved is a double displacement reaction. Double displacement reaction is a reaction between two ionic compounds where an exchange of ions takes place, resulting in the formation of products that are completely different from the reactants. So in this reaction, we'll be reacting sodium sulfate with barium chloride, resulting in the formation of sodium chloride and barium sulfate. Let's see this in the form of an activity now.
We have taken a solution of sodium sulfate in one test tube and a solution of barium chloride in the second test tube. And when we mix these two solutions, just see what happens. You can see the formation of these white precipitates. So the white precipitates formed are of barium sulfate because barium chloride reacted with sodium sulfate, resulting in the formation of barium sulfate and sodium chloride. So this is an example of double displacement reaction where you can see precipitates being formed. So you can also consider this to be a precipitation reaction.